Hey friends, welcome to our channel. So in this video, we are going to look at problem 848, shifting letters. Here we want to explain a solution based on line sweep algorithm. So actually the idea is very simple. We want to demonstrate this solution and then motivate you to solve some other problems. For example, you can try this shifting letters too. Actually, a lot of problems, like the similar problems to shifting letters 2, can all be solved using this line sweep method. Let's first look at the problem statement, and then we quickly explain the idea, and then we do the implementation. And in between, we're going to give some details. So here we have a string S, right? And also we give a list called shift. So we want to shift all the letters. So here the shift is like this. For each shift I equals X, so we want to shift the first I letters. In other words, from I plus 1 letters. That is from index 0 to index I. In total, that's there are I plus 1 letters, right? Then we shift X times. So here the shift is forwards, right? So for example, A becomes to B, and T to U, and Z to A, right? So actually this shift can be encoded by modulo operation. So you're going to notice this. So here we want to return the final string after all such shift to S. So here are two examples. So we can analyze one. Let's use example 2 maybe. So here are the constraints, like the length is 10 to the power 5. So this is a decent large upper bound. In other words, we need to pay attention to the time complexity of the solutions. And then the second one gives us it's all lowercase English letters, and the shift length equals the length of this S, and this is nothing special. And here the shift is in this bound, nothing special. So with that said, let's first look at one example, and then we are going to do the implementation, right? So here we have AAA, and these are the shifts. Then our idea, or this idea of implementation, is that for each index S, we want to count the overall shifts on it, and then we just do a map, then it gets the final result. So here, let's see, we have S is say AAA, and shift. Let's use shift. See, so it's at index 0 you're going to have 1, and index 1 you're going to have 2, right? At index 2 you're going to have 3. So that's actually the overall information. So here I'm going to use a dictionary. So the dictionary actually involves 4 indexes. Let's see, 0, 1, and so 0. 2 is also initially as 0. 3 also 0. So here 0, 1, 2, 3 you can understand as a length, right? So first shift 0 equals 1. It means that for the first letter, so because 0 plus 1 is 1, so we shift forwards 1. So what we are going to do is this. In the dictionary, we mark the start. So D of say 0 is incremented by 1, because we end at the second index. So we are going to do this. This I, right? This is I0, I plus 1. So it's going to minus the shift. So here is 1, right? So then if you look at this dictionary, so increment D at 0 by 1, so you're going to get 1. And then 1 plus 1 minus 1. It means that at this index we are going to decrement by 1, because from 0 ending before 1, so we are going to shift to the right by 1. So this is the first piece of information. And then this piece of information, notice that I is 1. In other words, for the first 2 indices, 0, 1, so we are going to move forwards twice. So what we are going to do is D0, we are going to increment by the shift, that is 2. And then DI plus 1, that is 1 plus 1, we are going to decrement by 2. So now what we have, the dictionary and D, and so this is going to change to be incremented by 2, that is 3. And then 1 plus 1 is 2, is decremented by 2, right? So this is the second piece of information. So now let's look at this last piece of information. It means that for the 3 indices, we're going to shift them to the right 3 times. So what we are going to do, mark the start, that is D0, so increment by 3, and then mark the end. So here index is 2, so 2 plus 1 is 3. That's why we have a 3 here, right? That's this 3 actually also equal to the length. So we have a 3 decremented by 3. So then the dictionary state will be this will be 6, right? And then this 3 minus 3, that would be negative 3, right? So this is the dictionary state after you put this information here, right? Then what we want to do is we do a prefix sum. So this prefix sum will gather or accumulate all the shifts. For example, D at 0 is just a 6. So D at 1, we're going to add the value for 0. So you are going to get negative 1 plus 6, that will be 5, right? And then 2, we're going to have negative 2 plus 5, that is 3. And at 3, for sure, 3 plus negative 3, that's 0, right? So then what does it mean? It means for index 0, the character at index 0, the character shift the character 6 to the right. Similarly, at index 1, shift 5 times, at index 2, 3 times. So now let's look at this. We have A, right? Shift 6 times, B, C, D, E, F, G, right? So then we have A got to G, right? A to G. And then at index 2, it's also an A, right? So we shift twice, so A, B, and C. Then we get this A shift to, let's see, 5 times, A, B, C, D, E, F, right? So D and E, F. So this will give us an F. And then the last one, 3 times, A, B, C, D, right? B, C, D. So we get A to D. Yeah, so the result will be GFD right here. So you can similarly analyze example 1. So here we don't go over that. So now let's look at the implementation. So first, here we do it in just for demonstration purpose. You cannot do this in a brute force way. So we can use a lookup table to do this, right? So first I imported the ASCII lowercase. So this is nothing but a string ABC up to Z, right? So the reason I'm use this because I don't want to type verbosely. What I'm going to do use this one is to build a dictionary, two dictionaries, I to A. So the index to character, right? So here, character for I, character in enumerate, ASCII lowercase. Similarly, I can want to do A to I. So I just need to copy and reverse the pair. So I can do this. Essentially, you don't need to do this because here I just want to demonstrate the idea. And also using dictionary, you can just, if I have the index, I get the character, and then what's the next after you do this shift. So with that said, this is just some preparation. So now let's get this dictionary first. So here I'm going to use collections default dict. So first I'm going to map everything to be 0, right? And then this actually is very convenient because when we do the prefix sum, we don't need to check if the key is inside the dictionary or not, and also we will have a key -1, right? So you will see this point. And then let's first put this shift information into the dictionary. So for I and n shifts, right? Let's see, enumerate shifts. And then what we want to do, mark the start, always this shifts, and mark the end, right? So I plus 1, right? Because for the first I plus 1 character, so they are going to end at index I. So at this index, we don't count this, populate this piece of shifts. So we are going to do decrement by n shift. Or you can use plus equal to negative this one, the same. So then you get all those. And then let's populate the information. So this can be done very easily because we use this default dictionary. So for I in range m, right? So we want to do the essentially prefix sum. So what we do is di, increment by di plus 1. So here we don't check if it's I in d or not, because when I equals 0, this one, I minus 1, is even negative 1. But negative 1 not in the dictionary yet, and this contributes to a 0 due to our treatment. So that's actually answers why we say if you use write like this format, it's very convenient. So now we have this piece of information. So we can print out this D later. So this D basically tells us that for each index, what's the shifts of the corresponding character, right? So now we can prepare the return. The result will be like this. We first use a list, and then what we want to do is to do this. We can join, right? This is just one way of writing this, but if you want to work primarily using a string, that's also okay. What we want to do for I in range n, right? So for the current index, first let's get the shifts, that is di, right? So this is the overall shifts at index I. So this is the corresponding to here. For each index of S, we count the overall shifts on it. So this dictionary state, after we do populate or compute prefix sum, will give us this necessary information or desired information. So we get this one, and then we get the letter after the shift. First, so we get A to I, so of the current letter at index I. So what's the index, and then plus the n shifts, right? And then actually we do modulation. We modulate by 26 because the length, there are 26 lowercase English letters, or the length of this string is 26. So this is the index for retrieve the letter, like here, right? And then we just do I to A, right? That's why here I used I to A and A to I. So notice that the purpose I introduced this to dictionary is to expose the idea or make it more natural or clear. In real coding, based on your preference, you don't need to specify this. You can use this function, the ordinal number, right, of a character. So if you can use a relative one, right, minus that's the A, right, then you can do similar thing. But here, I guess this is very natural. So once you get this letter, so what you want to do, you append this letter to the result, and then you, because we want to return a string, so you can do the join. And let's see. I guess, yeah, that's the full code for this problem. We can do a test. N is not defined. Let's see. for I in n, so n is the length of s. Let's introduce this variable. It's not necessary. You can write length n in this bracket. It's not right. Let's see what's the problem. So here, this dictionary is not right. Let me check that. So we have this one, lambda equals 0, and then the 0, this is the increment, plus equals that, right? Let's check that. Yeah, it parses the two test cases. For example 2, we actually manually run through, and for the first one, you see it matches. Now let's look at the generic case. It passes all the cases. So now I guess because we have printed all this, you can do an examination by yourself. So let me comment this out and make a submit, because sometimes if you have this part, it may have output exceed the limit. So with that said, here I want to make some comments. You can solve this problem, shifting letters 2, and there are some similar problems in shifting letters 2. You can solve most of them using the same idea here. So I guess with that said, that's about it for the current video. Thank you for watching.